Okay, we're going to learn a new rule called L'Hopital's rule, and this is a limit-taking strategy. And we didn't learn this when we were learning how to take limits at the beginning because you didn't know what you needed to know, and now you do. So we're going to go back and try to make some of those limits easier. The pronunciation is kind of L'Hopital's. If you Google this thing, about half of the entries have an S in there. I think that's because people say, "Oh, it's just like hospital," and then they add that S in. I might be mistaken. I don't know which one was the truth. And if Google didn't tell me, then I'm out of options. So L'Hopital's is how you say it, whether there's an S in it or not. So here's an old limit. If you substitute directly in this 7 in for x, which is the thing you try first when you take limits, just to basically substitute in, you're going to get the square root of 9 minus 3 on top, which is 0, and you're going to get 0 on the bottom. 0 over 0 is indeterminate. It is not 1. L'Hopital's is going to be used for 0 over 0 or infinity over infinity, and neither of these things are equal to 1, which is a tempting thing to say that they're equal to, but there are different levels of infinity, and 0 over 0 just doesn't act that way. So when you get one of these results by basically subbing in, you're going to use what you would have done an old technique, which we're going to review quickly, but now you'll use L'Hopital's rule. So let's do the old technique just to see what fun we're missing now. We would have rationalized by multiplying by the conjugate, and we would get x plus 2 on top, plus 3 times the square root minus 3 times the square root minus 9. All right, the reason you use the conjugate is so when you multiply it out, the middle two terms go away. And on the bottom, x minus 7 times the square root of x plus 2 plus 3. And usually it's best just to leave that, because what's going to happen on top is x plus 2 minus 9 is x minus 7. Those cancel, and we end up taking the limit as x goes to 7 of 1 over x plus 2 plus 3. And now if I substitute in the 7, I get the square root of 9 plus 3 on the bottom, I get 1/6. So if you try to sub in and get 0 over 0, an old way to fix that was to use the conjugate and rationalize. All right, so let's take that same problem and use L'Hopital's rule. So here's how it happens. If you sub in and get 0 over 0, take the derivative of the top and the derivative of the bottom. All right, the derivative of x plus 2 to the 1/2, which is what a square root really is 1/2 times x plus 2 to the negative 1/2. And the chain rule doesn't need to show up because the derivative of x is 1. So this is the derivative of the top. The derivative of negative 3 is 0. So that's the top. The bottom is just x minus 7. The derivative of that is 1. So when I take the derivative of top and bottom both, I'm going to simplify the top and make it 1 over 2 times the square root of x plus 2. And then the bottom of the fraction is 1, so I don't even really need to show that. Now take the 7 and substitute it in and see what you get. Get 1 over 2 times the square root of 7 plus 2, which is 1 over 2 times 3, which is 1/6. So there's that same 1/6, but without having to conjugate. By quickly taking the derivative of top and bottom and subbing in again, we've arrived at the same limit. So here's the rule. Here's what it looks like in symbols. The limit as x goes to c of f of x over g of x. So this is going to work for rational style problems where you have a fraction situation. It's the same thing as f prime of c over g prime of c. So the first thing we try is to plug that c in for x in the top and in the bottom. But if that doesn't work, take the derivative and plug the c in again. In other words, if you try to sub in and you get either 0 over 0 or infinity over infinity, take the derivatives of the top and bottom, and sub in again. Simple as that. It's going to save a lot of time on taking limits. So quickly, here's another old way. If you had a limit such as this one, what we could do is get a common denominator and add the top two fractions. Common denominator of 3x in the top, that adds up to x plus 3 over 3x on top. And then instead of dividing by 3 over x, I multiply by 1 over 3 plus x. Cancel those. I get 1 over 3x. Plug in negative 3 and get negative 1/9. So that's the old way. One of our old techniques was to combine fractions by getting a common denominator. I'm going to encourage you to pause right now and try this with L'Hopital's rule and see if you can get it that way before I go to the next one and we do it that way. Okay, so let's do this the new way. If we try to sub in again, on top you get 1/3 minus 1/3 is 0. The bottom you get 0. You're probably assuming this is what's going to happen, but don't forget that the first thing you should try is to plug in. You don't want to try any of these things if you can get the limit by simply plugging in. But when you get 0 over 0 or infinity over infinity, try the derivatives. Okay, so this should be the same as the limit as x goes to negative 3 of the derivative of the top, and the derivative of 1/3 is 0. And let me think of 1 over x as x to the negative 1. So the derivative of that is negative 1 x to the negative 2, and again the derivative of the bottom is 1. So let's rewrite the limit as x goes to negative 3. Negative 1 over x to the negative 2 is negative 1 over x squared. And the 1 denominator, again, could be ignored. Now sub in negative 3, and you get negative 1 over negative 3 squared. Be sure you actually square the negative sign on the bottom. Negative 1 over positive 9, negative 1/9. So L'Hopital's rule is one that can save you a lot of time, and it's one on the AP exam that definitely will show up once or twice. It's not a huge idea that shows up in multiple questions, but it's one that will absolutely show up once or twice, and it's easy to get that one right if you remember this rule.